kids, Miss Kulkarni here. In this video, we will continue with thermochemistry and work on more calorimetry problems. Just to remind you, calorimetry is used for capturing the heat released by a substance which is either being burnt or by a reaction. And the heat is captured by water. So what we measure is the temperature of water at the beginning and at the end of the experiment. And then we use the equation heat gain by water is equal to heat lost by the process or by the burning substance. Which formula we use? We use the formula MCAT, which is MC delta T. So here is our first problem. We have 1 gram of octane that is burned in the bomb calorimeter, and this is the amount of water, 1200 grams, and these two are initial and final temperatures of water. So we need to calculate the heat change when 1 gram of sample is combusted or burned. We're going to make use of heat lost is equal to heat gain by water. And heat gain by water will be MC delta T. Mass of water is 1200. C for water is 4.184. And delta T for water is final minus initial. So it's 33.20 minus 25.00. And when we calculate, we get 41170 so many joules. Now this is heat which is gained by water. So heat lost by octane, if I need to find out that will be exactly same value except the sign will be opposite, negative sign. Now remember, this is for 1 gram of sample, so we can say per 1 gram. Next step, we are going to find out the amount of heat in kilojoules per mole. So let's use our dimensional analysis in which we are going to convert joules to kilojoules, and this is per 1 gram. So we also can convert grams to moles. Kilojoules to joule is 1 times 10 to the third, and grams to mole, mole is number 1, and for octane the molar mass will be 104.6, and when we calculate, the final answer is negative 488, and that is kilojoules per mole. Now here is an interesting problem. We are actually heating 15 grams of copper sample to 100 degrees, and then we are dropping that into water, and we measure the temperatures initial and final. So let's find out first heat change for water, and we know the formula by this time, MC delta T. What is the mass of water over here? That is 100 grams. What is the specific heat for water? That's 4.184. And delta T, the final temperature is 25.35. And the initial temperature is 25 degrees. And when we solve that, the answer is 146.44 joules. Now this becomes easier because we know amount of heat which is gained is equal to amount of heat which is lost. So amount of heat gained by water was 146.44 joules, and copper metal is the one which is losing heat. So how much is that? It's actually same value except with the negative sign, negative 146.44 joules. And now using this information, we can actually find out specific heat of copper or any metal. Let's write down the formula for the amount of heat, and that is mc delta T. The amount of heat is negative 146.44. Mass of copper is 15. C is unknown, and delta T will be 25.35 minus 100. And when we solve for C, we get the answer 0.0784. That will be joules per gram per degree Celsius. So look at this. How simple was that? I hope you guys enjoyed the video. I will see you again in next video. Until then, bye bye.